Question 1. What is the order of magnitude of the mass in kilograms of an apple? So you need to be able to just guess what you would think the mass of an apple. Well, I would think a mass of an apple is around about 200 grams. So that's equal to 0.2 kilograms, which is about 2 times 10 to the negative 1. Now the order of magnitude, if this was, because you're at 0.2, this would be closest to 0.1, and therefore your order of magnitude is close to 10 to the negative 1, that one over there. If you had estimated, for instance, that perhaps it was about let's say 0.6 kilograms, then that would have been closest to 1 kilogram, which would have been 10 to the 0. Now we don't actually have 10 to the 0, and with these over here, they actually allow you quite a wide leeway, because I think all of you realize that you're certainly not going to get an apple usually of more than 1 kilogram. So question 2, the diagram below shows the forces acting on a body of weight W as it slides down a slope. The angle between the slope and the horizontal is theta. The normal reaction force on the block from the slope is N, and friction is negligible. So which of the following is the resultant force on the block? Now, because this is sliding down, there is no acceleration in the normal, so there must be a force cancelling out that normal force, and it would be a force down like that, which is a component of this W of the weight. And then you would have a force like now this would be the unbalanced force, or the net force acting on it. And if we have this as X, we would have X over W is equal to our sine of theta, just using our right angle trigonometry, because that's a right angle there. And so X is equal to W sine of theta. So A is the correct answer there. Going on to question 3, we have the velocity time graph for an accelerating object that is traveling in a straight line is shown below. So we've got velocity against time. Which of the following is the change in displacement of the object for the first 5 seconds? Now the displacement for a velocity time graph is your area, so we actually need to calculate what this area is here. And because that's just a triangle, we're going to have half the base, which would be 5 times 5, which is going to be 25 times a half, which is equal to 12.5 meters. We can see that our units work, don't they? Because we're going to have a meters per second times by a second, and those cancel out, and you're left with a meter. So B is your correct answer, 12.5. If they were wanting to find the acceleration, you would have to have found the gradient, because the gradient of velocity time graph is your acceleration. Going into this one over here, it says, some green, an object falls vertically from rest, air resistance acts on the object, and it reaches a terminal speed. Now terminal speed is a constant speed. Which of the following is the distance time graph for the motion? So it falls from rest, so initially we're going to have a 0 gradient, and it's going to increase, but then it's going to, and this would be our acceleration part, and then it should come to a constant, because this distance time graph, the slope would be the speed. So when the slope is constant, the speed is constant. That's what happens with terminal velocity. So it's actually going to be A, because here we have a constant, you have starting off at 0, it accelerates, and then we get the straight line over here, which is your constant velocity. Here you can see this can't be correct because this is actually starting off already with a certain velocity, and it's constant, and then it decreases. The velocity decreases. The velocity doesn't decrease, it stays constant. And I think you'd be able to see that C and D are both incorrect. So A is the correct answer for question 4.